Hi, everyone. Oh, I gotta look this way. Okay, good. So, I work for Unified. It's a social network for activists and organizers. So that's the QR code if you want to check it out. And I just want to give a shout out to my team at Unified. I work with some amazing developers. And of course, Simon, the dog, and Linux, may he rest in peace, the cat, who appears a lot in this presentation. So why are we even talking about topic modeling as search? So about a year or more ago, our CEO presented me with this mock-up, and he said, I want to help users on our platform discover trending conversations. And the idea was like you would see what was trending, what was changing. Of course, our platform has a lot of political conversations, so a lot of named entities that might come up. It's very news-driven. And I'm looking at us and I'm thinking, cool, cool, cool. I'll just build a topic model. This will be easy, or maybe it'll be hard. I don't know, but for sure it's a topic model, yeah? And then I looked at it again, and I was like, wait a second, you want me to do this in real time? Like, this brings a whole nother level of complexity to it, mainly because, you've got this mess of tagging posts and retrieving them. So I did know that I had to build a topic model. I didn't really know what the rest of this data engineering would look like, but I knew that. So I was researching vector stores and reading the documentation, as you do. We all read the documentation, right? And I noticed that Elasticsearch, which is one of the databases we use, pretty common database, natively stores dense vectors. So when you're building a topic model, one of the first things you have to do is you have to convert your documents into a text embedding. And a text embedding is just another kind of dense vector. But the cool thing was not only could you store text embeddings, you can also query the data store with text embeddings. And at that point, I thought, well, OK, if I can query the data store with text embeddings, what if I just created an embedding that represented the topic, and then I use that to retrieve all the posts, right? So yeah, I was like, this should work. There are a lot of benefits to doing this. First and foremost, I don't know if anyone has ever managed tagging things, but wow, you have a human label trading set maybe, and then you're trying to manage all the tags, and no sooner do you tag a post than it's already stale. Tags accumulate, you have to decorate tags, maybe you have to manage a taxonomy. It can be pretty complicated, right? And then on top of that, there's no built-in ranking, But search, right, you don't have to manage any of that. It's performant out of the get-go. The calculations are happening on the database side. It returns the posts in ranked by relevance, which is exactly what we want, right? And more importantly for me, I was like, and I didn't realize this at the beginning, only afterwards. I was like, oh, I can define a topic in advance. So if I know that an event is coming up, like say, I don't know, the elections, right? I can define that topic and start collecting conversation even before it starts trending. How many are familiar with embeddings and have used embeddings, like just about everything? Okay, I'm just going to briefly go through this because I think it's important to understand. But so text embeddings, you pass your text to a natural language model, say, sentence transformers in my case, and then you map that text to high-dimensional space, and then it starts discovering patterns in language. And of course, all your text is tokenized, right? So sometimes it's a whole word, sometimes just a subword. And then as the model is training, each of these tokens is given a position in this high dimensional space, right? So what you get back is a list of floats that's the length of the number of dimensions in that model. So in our case, I was using a very tiny model, all mini-4, 384 dimensions. So your text embedding, your vector, is 384 dimensions long. Again, as the model is training, similar text is positioned in this high-dimensional space closer together. So words that are close to Harry Potter or more frequently in the same context as that appear closer to Harry Potter, same with Star Wars, right? And it's all about the statistical probability that a word will appear in the same context. And then to understand, because it's in high-dimensional space and these are positions, we can, of course, measure the distance, right? In this case, we use cosine similarity. So if you have three vectors, if you look at the angle between the vectors, if the angle is smaller, then those texts are more similar. If the angle is larger, then the texts are dissimilar, right? So that's what we're doing behind the scenes in the search engine. The search engine is running cosine similarity, and it's returning the documents that are most similar to the text embedding that you pass to it. So again, a text embedding is just another kind of dense vector. Chances are you're running a database that already supports this. Most of the modern databases do, even Redis, which surprised me, right? And then to build this out, it is a bit of a complicated pipeline, I won't lie. First, you're going to have to pre-process your posts. So that means extracting the text. There's an art to this. I'll talk more about that. And then you're going to convert all of that, each of those documents, into an embedding, and you're going to store that in the vector store. Then, on the retrieval side, all your documents are in the vector store, so we train a topic model. That outputs a topic embedding. And the topic embedding is just another vector that's length 384 dimensions. So we're measuring the cosine similarity between the topic embedding and all of the documents in our data store. And the database is going to return the KNN, K nearest neighbors, to that embedding that you pass to it. And then on the back end, I'm going to rank the topics because I want to deliver the topics that have the most engagement, the most recent. And I store the topic embeddings in a cache, and then we can use those topic embeddings to query the vector store. So that's the sort of full system pipeline. The topic model itself is another pipeline, right? So again, we're going to have to pre-process that text. Remember, you have to pre-process it the same way because otherwise you're not going to be searching apples and oranges, right? And then you need to embed the text. You're going to reduce the dimensions. Then you're going to cluster. And then from each of those clusters, you're going to extract the keywords. And you're going to do it in a very particular way, which I'm going to talk about. And then the output is a topic embedding, which, as a last mile thing, you're going to pass to an LLM to give you a human-readable label, which is what your users are actually going to see. OK, so that was cool. I got this all built, and I was pretty excited about it, I have to say. But then I went to evaluate it. And so when you evaluate something like this, you're using a couple of metrics, but the most common are information retrieval metrics. So precision at K, which measures how many of the things that were on topic or assigned to the topic are retrieved in the first, and let's say 8 or 10 of your search results, which is what your user is going to see. And then recall at K. And recall at K is like, of all the things that were assigned to the topic, how many were returned in your standard search at, say, 100, where K is 100, right? So I was measuring this, and I started looking at the results, and I got this. The topic was cats, 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 and the post was, congratulations to the Minnesota House and Senate for passing. That was the top search result, right? Like, absolutely nothing to do with it, and I was like, oh gosh, I can't believe I have to, like, tell my boss this is not working, right? Yeah. This is not what you want to happen. So then I was trying to figure out why this was happening. And my first thought was, oh, well, obviously my topic model is terrible, which is true. The topic model is terrible. You can take a look at it. It's not, the clusters are overlapping and so on, right? The distance is pretty good, and the reason that this was happening is because social media posts are notoriously they use very common language across all the posts. There's not a lot of distinguishing language in posts, especially at the sort of small volume of posts that we had. So it wasn't really a problem with the model. The model was assessing it correctly. These topics are very near each other in the embedding space. And then I sort of thought about it a bit more and played with it, and I figured it out. So the deal is, if you're going to do something like this, where you're using a text embedding vector for search retrieval, you really have to think about how you create the embedding vector, the text embedding vector that you pass to the search engine as your query. And here's why. Let's say we have a topic, and so we want to create an embedding for that topic. What we're going to do is we're going to take all the documents in that topic and take the mean of those documents to create a single embedding vector that represents the topic as a whole. But here's the thing, it represents the topic as a whole. And when you search is finding the k nearest neighbors to the topic as a whole. So you're actually capturing documents that are outside of the area defined by your topic cluster. Whereas, if you define a more localized embedding for your search, in this case, I took the keywords, then what's happening is that embedding is very localized. When you search, the search engine is retrieving the k nearest neighbors of that more centralized embedding. The area that it captures is within the topic area. So more of your posts are going to be on topic. And so I made this change, and voila, here we are. Cats, which is, what we want, right? And even this post, I don't know if you can see, there's no text on this post, but here we go, cats. I obviously captioned all the images. But so I think that was one of the big lessons learned on this project, that if you are going to approach search retrieval using an embedding, really think about what that embedding represents. Okay, but that wasn't the only lesson learned, obviously. I think the other thing you should keep in mind if you're going to use topic modeling and then retrieve documents based on a topic, pre-processing really, really matters, no joke. Things like numbers, if you have the number 99, like 99 red balloons, and address and so forth, that will form a topic cluster, and you'll have a topic called 99, right? You want to strip at mentions or PII. You don't want a topic named after your CEO. I'm not saying that happened. I'm just saying you don't want that. You're going to want to filter some kinds of documents that may be less informative. In our case, replies are really short. They're like, cool. That's not helping your topic model, that's just noise, right? And then finally, we did use image captions at the beginning, but it did form some really funny topics, including my favorite, man in suit. So you have to really think about pre-processing a lot. Another refinement, I mentioned that I created the search embedding using keywords. At first, I used term frequency, inverse document frequency. I think you're probably all, how many are familiar with that? Yeah, so you're taking all the terms and then you're comparing that to all the terms in the other documents, and what it gives you is a sense of which terms make your topic distinct. The problem with that, though, is it surfaced very rare terms, things that just really didn't appear a lot in the topic. So it wasn't very representative of the topic, and you get some very oddly labeled topics. This really affected labeling more than anything else, because that's what I was passing to the LLM. So I changed it to use keywords, but the keywords were selected by comparing a sample of representative documents to the topic embedding and the keywords in those documents. So we're measuring cosine similarity again. So again, we're looking for semantic closeness. And when I passed the keywords that were most semantically similar to the topic embedding, my results and my labeling were much, much better. So I think that's another thing to consider if you're going to take this approach. And then finally, the last thing you have to do is think about the time window for your topic model. Okay, let's say you have a topic about cats and another topic about dogs, right? And then somewhere towards the end of that time window, there's the Supreme Cat Show, right? It's a cat show. It's in the UK. It happens every year. I don't know if anyone's heard of it. It's very exciting. If you have a long time window, what should happen is there's a cat show that happened on the prior day. That should appear as its own topic, right? But if you have a long time window, what the model sees is just more cats, right? It really can't cluster around that. It gets consumed by the more general topic. So to handle this, what I ended up doing was doing a long window topic model, which ran every week over the prior 180 days, and that surfaced evergreen topics, the things that are more stable. And then I would run a short window model, which was 1 week and had an hourly cadence, and that surfaced more emerging topics, right? And that seemed to work pretty well. So in conclusion, implementing semantic search is actually easier than you think. If you haven't done it before, I'd say experiment with it. Get really creative about what you're embedding. I think there are a lot of different applications for something like this. I can imagine if you have medical records and you want to compare cohorts and around their medical history, you could cluster on people's medical history, right? Or if you have a game and you have user-generated character traits and you want to find the characters in the game that are most similar or dissimilar to that user's character. We're going to be using it to help people find events in topics that they're interested in. So get really creative. You can get really creative about how you retrieve information if you think creatively about your embeddings. And then search embeddings really do need to be localized. And then finally, you can search smarter with topic modeling. So that's the thought, and I'm happy to take questions or talk to anybody afterwards.
Hi, thank you so much. Very interesting talk. I'm wondering if you have used this technique to track topics over time at all, and if that worked pretty well. We've tried to produce some topic models looking at changes in topics over time and have not had much success. So,
you could definitely do that. I mainly do it for debugging, to be honest with you. But I store all the topics that are generated in each run. And then you can measure the cosine similarity between them. You can do all the things that you would otherwise do. You can also introspect them. I highly recommend a package called BERT Topic, which is just sort of like a very, very conventional topic modeling pipeline. But Martin Gunsfert, who put it together, did a great job. It's really well built. But on top of that, he has some great documentation and great evaluation tools, right? But yeah, he can do that. And I think in that package, he actually has like a convenience method for looking at topics over time.
Thank you.
Yeah.
Microphone in the back.
All right, thank you very much for the great talk. You have a similar use case to something that I am working on personally. I'm working on an application that scrapes news headlines, and it is trying to get a general sense of what we as a news consuming public are considering in a given moment.
Yeah.
So every day it produces a word cloud. Something I noticed is that the context of a social media post or a news headline is really, really awful for doing named entity recognition for something like topic modeling. I'm wondering how you approach that.
Yeah, I actually used a named entity. I used Spacey. I extracted the named entities and added them back into my embedding. Something I didn't talk about here, but we had a workshop earlier in the week where we did this project. I cannot emphasize enough pre-processing, but one of the things I did is I took the unstructured text and I turned it into a structured document. What I mean by that is like you have a data model, a data class, in our case, Pydantic model for post, and then we have a Pydantic model for post document. And I take that unstructured natural language text and I break it into @mentions, hashtags, so forth. So I can be more explicit about what I'm including in the embedding and not including in the embedding. I can make a differentiation between what's passed the topic model and what's passed the search embedding and so on.
So is that like using a part of speech tagger in order to get much more granular with
Yeah.
your entity recognition?
Yeah, absolutely. So, and it'll tell me, like, if you've ever used Spacey, it'll give you persons, organizations, places, right? So I can also, one of the nice things about Elastic, if you were to do something like this, is Elastic does do a traditional lexical search, but you can combine it and have a hybrid search. So you could filter on, say, just Austin, right, using the named entity, if you do a structured document, and you structure your documents that way, and then pull all of the things that match Austin that are similar to your embedding, you know?
Thank you.
Yeah, yeah.
Cool. So I have a question about your pre-processing step. You mentioned that you got rid of one-word replies like cool and things like that. Did you just hard code on one-word replies? Did you have a set of specific replies, or did you automate this process, or was that by hand?
I was brutal and unforgiving. If it was a reply, I did not include it.
Oh, okay, I see.
Now, I had a conversation. Okay, so something to think about though, right? If you were tagging posts and doing it in a more traditional way, you wouldn't do that because that would mean that when you went to retrieve them, you wouldn't get them back. But in our case, we're just using the topic model for discovering topics. We're not using it for classification. So when we search, those replies are still there. They're going to come back.
Okay.
Right?
Got
The
it.
user's going to get the replies. I don't have to worry about that. I can just clear the noise out and really use my topic model for discovery.
I see. Okay. Thank you.
Great talk. 2 questions. One is, how is the LLM being used to actually read in the embeddings and return the human understandable label? Because I'm thinking embedding giant vector of floats. So
Oh, yeah. Okay, so again, this has to do with the tooling around the topic model pipeline. When you get a topic model back, you usually the old school way of doing it is the developer would introspect the topic by looking at the TF-IDF scores, right, and choose the words that are most closely associated with that topic. And I mentioned that I used similarity scores to do that. So instead of passing an embedding to the LLM, what I'm doing is passing the top K keywords for that topic, along with some number of representative posts, right, and some very explicit prompting, right? Which again, lessons learned. But yeah, so it's only getting text. But I will say this, like the embedding model I use is like the oldest, OpenAI. Like it's tiny, it's so cheap, right? It's like, we did this in the workshop with the llama, and it came out with great three-word labels. And it's just because you're passing it such structured information, right? And LLMs do a great job of summarizing, so yeah.
And the second question was, what kind of architecture are you using for the actual topic model itself? And then to train it, are you passing it the entire corpus of your, post history or something like that?
Yeah, I mentioned that I have 2 training windows for the base model, which is giving us the evergreen topics. I use a 6-month training window. And then for the sort of more recent topics, I use a 7-day window. And then, of course, there's a little management there, so I merge topics. So if the incremental model, the small window model, comes up with a topic that's, again, I'm using cosine similarity, similar to a more stable topic, I just merge them. Yeah, that way, like, you don't have weird topic label changes in the interface for the user. You're just, if it's a stable topic, they're just seeing that. It also allows me to edit display names for topics if, for whatever reason, the LLM gets it wrong. And I'm not saying that would ever happen, but maybe it might use ethnic names because they appear a lot in the post, and maybe you don't want that in the label, and maybe you didn't think about it, and then you had to update your prompt. But in the meantime, you had to very quickly change the label. Maybe something like that,
And the topic model itself is BERT-based, or?
Yeah. I used HDB scan. I like HDB scan a lot because not only can it handle unbalanced data, but all the documents that don't cluster well are assigned to -1, which is like unassigned, which means you can evaluate that. And actually, sometimes what I do is I run a model just on the unassigned, just to see like, oh, is it my topic model is not performing well, and maybe I can get a cluster out of this, but I just wasn't thinking about it, right? Yeah.
Thank you.
You got time for one last question.
So when a user goes in and searches, you don't necessarily know for a fact that they are going to pick a topic you already picked that like has the well-structured embedding. So if I just like search for anything, I guess, do you just like map it to the nearest topic and then retrieve what like is mapped to that topic, or?
No, actually, let me go. I don't know. I know that the mock-up is really small, but let me go back to it for a second. Oop. Okay. Yeah, it's hard to see, but in this mock-up at the top, there's a search bar. So if the user just wants to search for a topic, I actually use semantic search. I use the same technique, but I take the keywords that they've entered into the search, and I turn that into a text embedding, and then I find the similar documents. And then we store your searches so we can do some personalization so that you can see that topic. It's like you have custom topics.
Got it. Thank you.
Yeah.